All right, we got a little bit left to do in section 1.8. There's the special cases. Absolute values. And this is math 35. So there are 3 examples of special cases. If I have something like 7x plus 28, absolute value of equals 0. There is not actually 2 different answers here. Every other one we've done with absolute values, we've had to fork it into 2, but I can't make a plus or minus 0. So we just drop the absolute value signs and we need to find out exactly which one works. So there's, when it equals 0, there's no plus or minus. So we just solve. We get x equals -4. So special case 1 is where the right side equals 0. There's only one solution rather than 2. And now the big kicker comes along when we do I'll do the same setup for all of these right here. 7x plus 28. We're going to have less than or equal to -2. We're going to have greater than or equal to -5. Let's just make them different. What is the smallest value that this can take? As an absolute value entirely. Not looking at the like the 7x plus 28. What's the smallest value that something in an absolute value could get? 0. The smallest value it can be is 0. Because if it goes negative, any negative value just becomes positive, and that's greater than 0. So the lowest scenario I have here is 0 is less than or equal to -2. Does that work? Is 0 less than -2? No. Which means any other value that it can take has to be a higher value. It's also not less than -2. This has no solution. Same logic applies to this one over here. Again, the smallest value is 0. So I could have like 0, 1, a billion. But we look at the smallest one, 0 is greater than or equal to -5. That's a true statement. Which means every number larger than it is also a true statement. So every value I can get is greater than -5. which means X is any number. And the way they write that in mathematics, they say X is a member of the real numbers, where that crazy looking R is real numbers. That's a dead green pin. I brought extras. So absolute value actually shows up a lot in trade stuff, where what you're looking at is a margin of error. It also shows up in other things like the average or a human is considered healthy if they are within, I don't know, 3 degrees Fahrenheit of normal body temperature. What temperatures are a healthy range? I just made up the 3 degrees. I don't know what's the official value where they consider you're sick or you're not sick. I think this will work. So when we want to be within 3 degrees of it, a healthy human body temperature is 98.6 degrees Fahrenheit. So we can do X minus 98.6 degrees Fahrenheit. Put absolute values on it. And then you say it's less than the error or margin of error goes on the right, which is our 3 degrees Fahrenheit. This also works in stuff like machinery where you we need the nut for bolts to be within 1/16 of an inch, either larger or smaller than, and it will still screw on without being not fitting or being too loose. You can do the same thing like this there and find out what nut sizes or bolt sizes, whatever you're doing, work. But if we do this ends up being, when we bust it out of the absolute value, since it's the less than, it makes the sandwich. We've got -3 and 3, we're going to sandwich it in between it. And I dropped the Fahrenheits for now, we add it later. Now we're just adding 98.6 to each side. So that's like a healthy body temperature range. Not everyone runs exactly 98.6. It's the average for the population. Good stuff, right? Was that everything you'd hoped it would be? And then some. It was even more than better than you could possibly imagine.
Okay, so you're kind of like applying like what we learn in math in real life, and what we use it for.
Yeah, we actually use math in real life. Imagine that.
Yeah.
All right, let's start chapter 2. Chapter 2 is on graphs and functions. So 2.1 is on the rectangular coordinate system and graphs. The rectangular coordinate system is also called the Cartesian coordinate system. Named after Descartes. So the way the Cartesian coordinate system is, we make a graph with a vertical line and a horizontal line. And these two lines are called the axes. Each one is an axis. The plural of axis, when there's more than one, it's axes. Which looks like axes, like weapons, like wood cutting shit. Along the flat one, the horizontal one, we do X values. And on the vertical one, we do Y values. And we usually have some little indication of how values go. Little hashtags to show values. When I'm drawing them, I tend to make every fifth one a little bit bigger of a line. It just helps me count them later on. The center is 0 for both of them. And as I go right along the x-axis, it's the positive direction, and left is the negative direction. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you do this little hashtag thing where like every fifth one is longer, you can save yourself some work by just putting in those values and going from there. That way you don't have to number every single one, because that's lame. It's also confusing on your graph. So if we have a random point on the graph somewhere, let's say it's right here. We define points in terms of a coordinate pair, an ordered pair, X, Y. This is called an ordered pair. And this is absolutely why I hate their parentheses notation for intervals that use parentheses, because it looks exactly like a coordinate. So what we do is we go and we look along the x-axis and figure out how far left or right this dot is. It looks like it's 1, 2, 3 dots to the right, and 1, 2, 3, 4 up. So my X is 3 and my Y is 4 there. This point is 3, 4. So if we look at what happens in general, in this upper right quadrant, it's always positive and positive. X values and Y values are always positive. In the upper left quadrant, the left values, the X values are negative, the Y values are still positive. In the lower left category or quadrant, they're both negative. X and Y are both negative in that quadrant. And in the lower right quadrant, the X value is positive, but the Y value is negative. So if I did another point over here, I could figure out what it is by coming over here. This looks like it's at the -6 line for the X value. And for the Y value, it looks like it's down 3. So -6, -3. I can do that with other points. I put one there. Let's put it there. That looks like X equals 10. And Y equals -5. That would be 10, -5. That dot would be -6, 5. And the most important dot on the board is the center. This point right there where they cross is called the origin. And it's 0, 0. So I'm going to use this value right here. I'm going to grab the -6, -3, and I'm going to grab the 3, 4, and we're going to find the distance between these 2 points. So I'll kind of do a quick sketch of it right here. It won't be 100% accurate, but -6, 3, we'll put that right there. For -6, -3 is right there. And then 3, 4 is right about there. Without putting any hashtags in. We had the graph above. And if I wanted to, like, if I made a line connecting them, I could find the distance or length of that line. We'll call it D. I'm going to call this my first point because it's on the left, and this will be my second point because it's on the right. But that's actually arbitrary for what we're going to do next. You can label either one whatever you want. With this being the first point, I'm going to call this point x1, y1, where the subscript tells me which point it is. So the subscript says which point. Which means this one here would be x2 comma y2. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I plug those in, I can do it in this problem. Let's just see what we get. I've said x1 is -6. And x1 goes right here. And these were both minuses in the parentheses. And my y1 is the last one in the second parentheses. That was -3. That goes over here. My y2 point and x2 point, x2 was 3. That goes in front here. And y2 was 4. That goes right here. So I get the distance is the square root. 3 minus a -6 is 3 plus 6. That's a 9. And we're going to square that. And this is 4 minus -3 ends up being a 7. And we square that. So I have the square root of 81 plus 49. So D is the square root of 130. So I don't know, 11.3-ish, something like that, maybe 11.4. Let's give you guys a problem, work it out and give it a try on. Find the distance between -5 and let's go with 7. And we'll go with 2 and -4.
So Jones, I just got a question, like the first page, like of chapter 2.1. How you spell that in the first one? Recantular coordinates?
Oh, fuck. I fucked that up.
Oh, I'm sorry.
No, thank you. That should have said rectangular. Like rectangle. What I wrote was complete garbage.
Angular.
No one said a goddamn thing. My shit says rectangular. Rectangular?
Yeah.
Ain't no one said a damn thing. Just let me look like a moron. Thank you, Josue.
You
Welcome.
belong in a pond. You're being a silly goose.
Yes, that's what it was. It was deliberate and I was being a silly goose. That's some shit my wife says. My wife calls me a silly goose. Crazy. Let's see what happens.
Yeah, accidents happen.
That's just me getting ahead of myself and I have no excuses really. I don't know what the hell happened. I'm glad you asked. That's gonna be embarrassing to have up. Maybe I just won't post this entire video because yeah. All right, so who picked what to be which point and which point? Did y'all pick this one to be 0.1 and this to be 0.2? Did anyone pick the other way? Good, I'm gonna pick the other way. So I'm gonna label this 0.2 and I'm gonna label this 0.1. Just to show you, if you work it out the other way, that you get the same answer. So this will be my x2 and my y2, and this is my x1 and y1. X2 minus x1 is -5 minus 2 squared. Y2 minus y1 is 7 minus -4 squared. I get -7 squared plus 11 squared. I guess I made that a little bit long right there. So that's the square root of 49 and 121, which is the square root of 170. So if you did it the other way, you should have also gotten that. The reason why it works that way, it doesn't matter which order we put them in, when we square it, it makes the sign positive no matter what. And so we're actually just looking at the distance between them. Now, the way this is fuck upable, if that's a word. It is fuck upable. The way you fuck this up is if you don't put the X's together. I did -5 and 2 here, and I did 7 and -4. If I had done -5 and 7 all in one parentheses, and then 2 and -4 in one parentheses, it would have been wrong. So it's a very, very particular formula.
Like how you said when you first explained absolute value is used to represent distance.
Yeah. That is how I explained it, isn't it? I must have been thinking ahead. Every once in a while I have a good moment. And then you get your rectangular. This actually gives us one means to test if 3 points make a triangle. So we'll take a look at that. Pythagorean formula. For a right, I guess any 3 points do make a triangle, but for them to make a right triangle.
I just have a question, like in the other page at the end, what you wrote, I couldn't like finish writing the red thing.
Oh, it's the one I had already written at the top of the page.
I didn't see it. Thank you.
Uh-huh. So if we call the longest side C and the two shorter sides A and B, the Pythagorean formula says for a right triangle, and they generally depict a little square in the corner for a right triangle, depicts that it's right. We can do a squared plus b squared equals c squared. So what we're gonna do is we're gonna have 3 points. And we're gonna determine, oh, for a triangle, these are called vertices. Well, a single version is vertex. And when you have more than one, they're called vertices. So the plural of vertex is vertices. And the vertexes are the points. That's just extra fun information for you. Determine whether R being 0.0, -2, S being 0.5, 1, and T being -4, 3 are the vertices of a right triangle. All right. So what I'm gonna do is I'm gonna start off, I'm gonna like try to sketch it. This isn't necessary to doing it, but I think it kind of helps. Just to kind of visualize what's going on. And since I didn't use graph paper, this is not going to be exact. Yeah, and the horizontal axis is the x-axis. The vertical axis is the y-axis. So R is 0, -2. What I'm going to do is this tells me to go left or right 0 and down 2 because it's negative. So that'll be point R. 5 says to go right 5 from the origin and up 1. That's my point S. And my point T is -4, so left 4 and up 3. Let's see. T. So I'm gonna like connect the dots, see what we get. So it might be, if it's a right triangle, that would be the right angle, maybe. So this means this is the long side. I need to know if the side between T and R or RT like that shows me that side. It's called a line segment. If I do RT there and RS here and ST there, I'm just picking the endpoints or the points on the end to describe the name of it. I need to know if RT squared plus S or RS squared equals ST squared. So we start writing them out. I'm going to use whatever letters in front as 0.2. That's just the way I'm going to write it. So for my RT, I'm going to do 0.2 is R and 0.1 is T. So point R goes first, it's 0 and -2. And then my T goes, and my T is -4 and 3. That's the square root of 4 squared plus -5 squared, which is the square root of 41. Now I'll do RS. So same setup, I'll do the R is the first, or is 0.2, so it goes in front. 0 and -2. And then I have minus signs. And S is 5 and 1. That's the square root of -5 squared plus -3 squared. 25 plus 9 is 34. Finally, we'll look at ST. So I got 5 is the x2 and 1 is y2. And T has -4 and 3. I got 9 squared plus 1 minus 3 is -2. This is 81 plus 4 is the square root of 85. So I need to know is square root of 41 squared plus square root of 34 squared. Does that equal square root of 85 squared? I'm getting 75 on the left and 85 on the right. So even though it looks like it might be a right triangle, it's not. 75 does not equal 85. It is not a right triangle. So this is what happens when we square them and add them and check to see if they equal. So check this out. What if we just do something like I've got 3 edges and I go A plus B equals C. Well, if this is the distance, if this is A is the distance between 2 points, like let's say it's RS and B is ST or RT. And C is ST. If this situation happens without squares, it means they're called collinear points. They all lie on one line. So let me give you guys a problem to try. Let's see, what do we want? We're gonna use P, Q, and R. P is -2.5, Q is 0.3, and R is 8, -5. Are these collinear? I'm gonna plot them. Let's see, 8, -5 would be over here, that would be R. 0.3 is up here, that's Q. -2.5 is somewhere up there, it's P. I didn't put them to scale, I just arranging where they are. So if they are a straight line, PQ plus QR should equal PR if they are, if it's one line. I'll give you a chance to practice it, see how you guys do. Two point one is how long, 2.2 is how short, super quick. Like we got a lot of shit to explain in 2.1. How the graph table works, shit like that. 64 and 64 is. And you know what? I don't know what any of those values fucking equal. So. I'm gonna calculate this bitch. So I've got. PQ is 2.828427. QR is 11.313709. This rounding. What do those add up to? These add up to 14.142136. Now, the question is, what is square root of 200? $14.142136. I think without the rounding, I think those are pretty spot on. I'm going to say those are all in a line. The tool that will help you guys until everyone's done writing. And just remember, you won't have this on the test, so you should really only use it to check your work and shit like that. Desmos. So if you come over to Desmos and you're grabbing calculator, we're able to plug in things like a line, and we'll plot the line. Or we can just plot points. So I had -2.5. And I had 0.3. And I had 8, -5. Ooh. So it's a little hard to tell.
Wouldn't it be easier to tell if they were collinear points if you just compared the rate of change? Like, for example, to go from point P.
We haven't gotten there yet.
Okay.
But then it's a good idea, but it only is true. Yeah, kind of.
Because it is true in this case.
You're meaning the slopes. What is the slope here? Rise over run is 2, or it's a slope of -1, right? So I have the line y equals, we haven't covered this yet. And I can see all 3 points lie on it. We're getting there. Chapter 2 is a big chapter. Wait for it, Chris. Gotta start with the basics. So Desmos is pretty handy. When we're looking at lines, Desmos is really handy because you can put in a variable and make it a slider. Right now, A, the number, and this is the equation of a line, we're gonna be working with them more. When A is positive like it is now. Notice that it goes uphill as it goes to the right. In fact, the larger A is, the steeper that hill is. As soon as we get down to A is around 0. Oh yeah, getting pretty close to flat. And when A is 0, it is flat. And when A is negative, the value in front of X, it's now downhill going to the right. So we'll come along, we'll do more with that later. Just dabbling with Desmos while we're there. Some other stuff we can do with 2 points is we can find the midpoint. So the midpoint equation is you add the 2 x values, divide by 2, you add the 2 y values and divide by 2. Let's try that on Q and R up there. Q and R. So midpoint for Q and R. I'm going to add the 0 and the 8 and divide by 2. I'm going to add the 3 and the -5 and divide by 2. And I should get 4 and -1. 4 and -1 is about there. So maybe that's halfway between those two. Well, not maybe, it is. So these actually are the X and Y have a value. This is just some fun facts. I'm not testing you on it, but if you see it anywhere, this is what they're talking about. The X value is called the abscissa. And the Y value is called the ordinate. The Y. I got no idea. I do know abscissa makes a great Dungeons and Dragons character name. I use it on World of Warcraft for a rogue. Sounds like abscess or like it's a disease or some shit. So I made it a rogue. So that's another fun fact for you guys. What else we got in here? Yeah, this is something that they will have you do in the Homer that I probably won't test you on, but it's fun. So if the midpoint is 4, -4, and one of the endpoints is 8, -20, find the other endpoint. Give me a second to write down before we do it together. In fact, I'll even give you a couple minutes to try to reason out what you could do with the midpoint formula and how to get it. See if you can intuit it. Ugh.
Mr. Jones, I couldn't finish what is in the other page. Just a little bit. I missed something a little. Yeah. That one. I'm done. Thank you.
So if I kind of like label it the way I see stuff here. Like in the midpoint formula, this is saying 4 negative 4 equals. Let's call this x1, y1. And we're trying to find x2, y2. This is saying that 8 plus x2 over 2 and negative 20 plus y2 over 2. That should equal 4, negative 4. What can I do with this information?
Set x plus x2 over 2 equal to 4.
I can set the x values equal to each other, right? Oh, not x squared, but x2. And I can do the same for the y values. So I'm going to multiply both sides by 2. I hate using fractions. I think the easiest thing to do is just multiply both sides by 2. I get 8 on the left and 8 plus x2 on the right. If I do it on this equation, I get negative 8 on the left and negative 20 plus y2 on the right. Now if I solve for x, I get 0 equals x2. If I add 20 to both sides here, I get 12 equals y2. So the other endpoint is 0, 12. Ready for some more? Nope.
Just give me a minute, just give me a minute.
Yeah, sorry, I looked up and saw that I was rushing people in here too.
Do you want to hear the way I did it?
How did you do it?
To get from 4 to 8, you go right 4. And to get from -4 to -20, you go down 16. And so you just do the opposite from the midpoint. So you go left 4 and up 16.
Okay. That's not always easy. In this case, it was easy because there are whole numbers. All right, so let's look at some more stuff to do that we can do in this class on this topic. Like finding ordered pairs from an equation. So let's say I've got y equals -2x plus 5. I can make a table. And I can just start plugging in values. So I'll just do like -2, -1, 0, 1, and 2. If I plug in -2, got -2 times -2 plus 5. -2 times -2 is 4, plus 5 is 9. And I could do the same with y equals -2 times -1. And then plus 5, so I'm gonna do the -1 line. -2 times -1 is 2, and then plus 5 is 7. And if I do x equals 0, I got -2 times 0 is 0, plus 5 is 5. You'll notice that going from each one to the next one is -2 when they're only one apart. And this is something that happens when we have a line. The -2 right here ends up being the little step between each y value when we do one value in x. If it is not a line, it's going to be something different. So I could fill in the rest of the graph by subtracting 2 each time, following that pattern. Something that actually helps to graph, which we're going to do in a bit, is doing not only where x equals 0, finding where x equals 0, but also let's find where y equals 0. So let's find X here. So if I do that, I got 0 equals negative 2x plus 5. And if I solve for this, I get x equals 5 halves, which is 2.5. So when we have x is equal to 0, if we look on the graph, when x equals 0, we're actually on the y-axis. And when y equals 0, we are on the x-axis. So for this reason, since if I draw the 2 points that I have for those values, I've got 0, 5. And 2.50. If I connect the dots to make a line, I can see the graph that way. And so for a straight line, you really only need 2 points to make the graph. Where it crosses the y-axis, this is where it's if you like football, it's kind of there. If like the receiver's running, trying to catch the ball, and they cross this, crossing the defender, this is an intercept. This is intercepting the y-axis, so it's called the y-intercept. And I usually just abbreviate it y-int. And that value is called the x-intercept. And I call that x-int. So by the name of it, it's where the other letter equals 0. Y-intercept, x equals 0. X-intercept, y equals 0. So it's like the other letter equals 0. For straight lines, that's all you need. 2 points for a straight line. They're not all straight lines though, so let's take a look at how you graph non-straight lines. Let's do another equation. Let's do x equal, oh, this is good. X equals the cube root of y plus 1. So we have two options here. One of them is just to solve as is. And I think it's worth doing just so you get used to realizing that you don't have to just plug in x's. We can plug in values for y to plot this graph. If I want something that doesn't look shitty though, I want this to end up being a cubed value. Like 0, 1 and -1, maybe 8 and -8. Because then I can take the cube root and get the left side pretty quickly. If I don't, I need a calculator. So I can see where I want 0, that's like the middle of all these. If I set the center equal to 0, I could see at y equals -1, I get 0 in there. -1 plus 1 is 0. So the cube root of 0 is 0. If I want this overall thing to be, like, let's see. I had that being 0. I kind of want like -1, -8, 1 and 8. So if I solve for the y values from this, I could do that. And now I'm taking the cube root of this right. I made 3 columns here. I want the cube root of this column. Cube root of -8 is -2. Cube root of -1 is -1. Cube root of 1 is 1. And cube root of 8 is 2. So I want to graph these ones. You gotta literally just go through and grind out the table. -2, -9 is left 2 and down 9. -1, -2 is right there. 0, -1 is there. So it looks a little weird. Like if I just went with my intercepts, which is these 2 points right here, I would think it was a line going like that. But it's not. I got points up here and down here. So when you don't have a straight line, or when you, if it's not, this is like the form y equals mx plus b. If there's any other exponent anywhere on a y or an x, it's not going to look like a straight line. So I got to connect the points, and it looks like like shit's changing here at the middle. So if I start here and go to the right, it looks like it's curving up. And over here, it looks like it's curving down. Another way we could do this is we could solve this for X or solve this for Y. We're gonna solve for Y. I want to get Y by itself. So right now, Y is trapped underneath a cube root sign. I'm going to cube both sides. That gives me X cubed on the left and Y plus 1 on the right. Now, if I subtract 1 from both sides, I get Y equals X cubed minus 1. And I'd still have to make this table. Or later on, we're going to learn techniques for graphing cubes and squares. But in this first section, we're just going over how to plot the damn shit. And not doing like particular graph shit. Except in 2.2, which we're about to start, which will take less than 30 minutes. If I do this right. 2.2 is on circles. So let me give everyone a chance to catch up on this. Does anyone need this up longer? All right. 2.2, circles. So a circle, the fucking Jeopardy answer for you is the set of all points equally distant from a single point. The single point is the center of the circle. And the distance they are from it is the radius. R equals radius. A little bit more information about a circle is the line goes directly through the center and hits both sides. The full length is called D, the diameter. And you'll see that D is just R plus R. Or 2R. All right, so for the equation for a circle. With radius R. And a center at HK. Is x minus h squared plus y minus k squared equals r squared. So like if I have a center at 1, -2, and a radius of 3. I'm going to have, this is my H and this is my K. That's my R. I'm going to have x minus 1 squared plus y minus k, which is -2 squared, equals 3 squared, which is r squared. So x minus 1 squared plus y plus 2 squared equals 9. The easiest way to graph this by hand . Find the center, put a dot there. 1, -2 is right there. And don't try to go like a distance of 3 in a diagonal. Go a distance of 3 up and down, left and right. So if I go over 1, 2, 3, I could put a point there. I can go left 3, put a point there. I can go up 3 and put a point there. And I could go down 3 and put a point there. So like this is my center right here. And what I'm doing is just adding the R in every direction. R equals 3, so I went 3 that way, 3 that way, 3 that way, and 3 that way. And now you just kind of connect the dots. What about a circle with a center of 0, 0 and a radius of 1? So that's my H and that's my K and that's my R. So I have X minus 0 squared plus Y minus 0 squared equals 1 squared. Or X squared plus Y squared equals 1. This has got a name, it's called the unit circle. The circle centered at the origin with a radius of 1. You'll need to do it a lot in trig. You need it a lot in trigonometry. And so if I wanted to graph it, I would make my graph around the origin. Put my center at the origin. And now I want to go R. R is 1. That happens to be R squared also. So make sure you're only doing the square root of this number over here. And I'm going to go that distance in every direction. And connect the dots. Sometimes we are not given that information in that form now. What if I had something like this? When you have both x squared and y squared, I'm going to say ax squared and a bx squared. And if a equals b, doesn't matter which value it is, in this case it's 1. There's a good chance this is a circle. So the way you get it in circular form, the equation of a circular form, is we're going to try doing that completing the square business we did with lines the other day. I'm going to group up my x's in one spot. I'm going to group up my y's in one spot. And I'm going to actually add the 44 to the other side. So I'm going to add 44 to the other side. We did this with completing the square the other day, last week, or the week before, to find the solutions for problems. If I complete the square here, as a reminder, we take that, we divide it in half, and we square it. Four divided by 2 is 2. 2 squared is 4. I'm going to add 4 to both sides. And just like we did when we did completing the square, I can take that and drop that right in my little parentheses for the x. So we do the same thing with the y. I'll take the -8 and divide it by 2. And I'll square it. -8 divided by 2 is -4. -4 squared is 16. So I had 16 on the left, I'm going to add 16 on the right. And I can put this in parentheses. By completing the square. The right side, we just add up and I get 64. So, where's the center? You want to say 2, -4, don't you? That's not it though. Remember, the equation has x minus h squared and y minus k squared. So whatever goes here is the opposite sign of what's there. It is very much a natural intuition to want to do that though. What's the radius? It's a big circle. It's not 64. It's 8. Remember, the right side is r squared. So we had r squared equals 64. And we talked about solving this a couple weeks ago. Take the square root of both sides. Technically, we get r equals plus or minus 8. Technically, by solving it. But radius is a length. And nothing has a length that's negative. So no negative lengths. So that cancels out the -8 part, and it just becomes +8. I'll give you guys one to do. And my pro tip here. Get rid of the 2. On the x squared and y squared. I divided everything by 2 and I started arranging shit. This doesn't make for some very friendly values though. If I cut that number in half and square it, I get 1/4. If I cut that number in half and square it, I get 9/4. This isn't too bad. I just take the 1/2 and throw it in the parentheses. And I take the -3/2 and I throw it into parentheses. The right side, cleaning it up. I've got 45/2, 1/4, and 9/4 all added together. I could get a common denominator. I see something that you may not recognize right away. If I add these two together, I have 10/4, which is 5/2. And so if I add up 45/2 and 5/2, I get 50/2, which is 25. So what's the center? Of the 3/2, yes. What's the radius? Square root of 25 is 5. Now, just like the absolute value problems, there's special case scenarios for circles. So special case scenarios for this equation, I should say. Case A, when r squared equals 0, we have no radius, which means no distance from the central point. And if we don't have any distance from the central point, we at least have the point at the center. All we have is a single point. The center. The other example for absolute, just like absolute value, is when r squared is less than 0. Like x minus h squared plus y minus k squared equals -1. Now, we don't even have the point. This is a non-existent graph. We can still have the equation, we just can't graph it. So it doesn't really hold a lot of weight like in the real world. It's kind of wet. I can't wait till I go lock the door on the staff students. I'm gonna just show you one thing. We're not gonna solve anything. This is how they find the epicenters for earthquakes. Epicenter being like ground zero, where did the quake happen? So they'll have 3 different stations. And they will be able to tell how far away the earthquake was. But not the direction. You're in a building, the building fucking starts shaking, you don't know which way the earthquake came from. But let's say like building here is the A is there, B is here, C is here. They know how far away it is, so like it makes like a circle around the building. If I drew that as a better circle, that would be fantastic. That is a shitty circle. The first 2 houses or the places they do it, narrow it down to 1 or 2 spots. It's gotta be either here or it's gotta be here. And so they do some, like they plot it, they do some convergence, and that's the epicenter. And that'll be it for today. And we're caught up. Told you we get caught up.
Bye. Thank you. Have a great night.
You too.
Thank you. See you Wednesday or
What?
Tuesday
You're
and
leaving now?
Thursday.
Thursday.
See ya.
Bye-bye.
Sure. Hey, wait. Don't leave, wait. Can you hear me?
Uh-huh.
Oh, let me take a picture and then let me add you something. Sorry, I take some time.
Okay.
The notes. When is the drop date of your class?
It's on the syllabus.
Oh, I didn't find it there.
It's at the very front of the syllabus. I
Okay, let
can,
me. It's not yet. I think the drop is
it's like March 24th or something like that,
because hell, I didn't find.
right here.
I didn't find it. Oh, well, March 24th. Yeah, I just wanted to know because I'm having a lot of trouble. I don't know if I'm gonna drop some classes, but I think this one not. I just want to know.
Okay.
Thank you, sir.
Uh-huh.
Have a good day.
You too.
Being the best, it's hard work.